Welcome to this presentation entitled Designing Reports for Performance. It was originally delivered at Information on Demand 2012. This presentation takes a ground-up approach to designing reports for performance by looking at data access strategies, modeling design and techniques, and of course report authoring techniques. Initially you may feel that this title is slightly misleading because we're going to spend a lot of time in theory up front. But it does bear repeating, and it is important information for you as authors, modelers, or even administrators to know. Before I get into the details of the presentation, I typically pull up this slide and ask authors in the audience how many of them have reports that look like this, that have complex joins, unions, custom SQL embedded into the reports. Or they have recurring calculations or complex calculations that they have to repeat over and over again or may be resource intensive. And inevitably, most hands in the audience go up. And the reason they have reports like this is because they're simply just working too hard. The data access strategies employed in the BI project are not really meeting the needs of the author or the end business users. And also the model may be poorly designed and not meeting the reporting requirements. So let's take a quick look at the problem. What might cause authors to create such complicated reports? The typical BI project situation involves tight deadlines. Modelers end up using the available data sources because there's no time to create data marts or data warehouses. The project management team will make do with available resource skill level, so there may be inexperienced people working with Framework Manager or Report Studio or whatever studio they may be using. They create the model and the reports. They rush to get these reports into production, and performance is not acceptable. The result is the project is in jeopardy. So the complication in this situation is the tight deadlines equal a we have to deliver something situation. And that situation will lead to poor reporting data sources or data access strategies, potentially lacking skill sets for the tools that are going to be used in the BI project, and little attention given to performance testing. This happens over and over again where performance is only tested in the very last stages of the BI project, and then we find that the performance is not acceptable, and of course the project is in jeopardy. And of course, lack of user testing. Have the end business users tested the reports to make sure that A, they meet the requirements, the performance is acceptable, and so on. The implication of this situation is that the delivery of poor performing reports may mean that the deadline has been met, but the project's at risk. And it's at risk because users will simply not accept these report response times. The position we're going to take in this presentation is that yes, there are techniques to tune models and reports, and I am going to show you several of these, in fact the ones that we most commonly see in the support organization. But as a general rule, performance starts with a good data access strategy plan. So even if it delays the aggressive deadlines of your BI project, being an advocate for a good plan will ensure that you get these accurate and quick responding reports, which will ensure the success of your BI project. So the roles addressed in the following are project managers, administrators, modelers, report authors, QC, amongst others, including database administrators. Everyone in the BI project should be aware of this information. It allows them to contribute to the BI project plan, and it defines accountability. So who do you talk to when you run into a problem? For example, a report author may find a key piece of information missing in the package that was published up into Cognos Connection, who in turn will talk to the metadata modeler. The metadata modeler may find that the key piece of information is actually not in the data warehouse, and he can then notify the project manager and the DBA that this piece of information is missing. The benefits of the following information is that proper data access helps ensure a BI project that will perform well and return expected results. And modeling and report design best practices will help ensure reports are tuned, durable, maintainable, and consumable. So here's a quick look at the agenda for this presentation. First, we'll look at data access strategies, followed by model performance and design, which will take place in Framework Manager. and then report performance and design, which will take place in Report Studio. And the version of IBM Cognos BI that we'll be using throughout this presentation is 10.2. So the first and most important part of designing reports for performance is the data access strategy plan. Again, some of this information may appear to be common sense, but it does bear repeating. And before we define any data access strategy, we need to look at project management in general. And for a BI project, we need to gather the user requirements first. The user requirements will feed into what the report requirements will be. And based on what the report requirements will be, we will define what the model requirements need to be. And the model requirements will dictate what type of data source we need to go after. Once we have all that information, we then design the model, design the reports, and get users to test and accept those reports. Once you have your requirements gathered, here are some key questions to ask about your data while creating your data access strategy plan. First of all, does your data support your business questions? And if it doesn't, what can you as a company do to ensure that you get access to the data that you do need? How many data sources are there? Are they distributed across multiple database vendors or multiple geographies? Are you considering using any federation technology to bring that data together, or consolidate it into a warehouse, into a centralized location? How much data is there? Will you be using anything to optimize accessing these large data volumes? For instance, some form of materialization, or building aggregate tables, or partitioning your data? And how will this data volume affect your queries in general, build times, and test times? Will users mainly be viewing summarized data? And if so, again, think of aggregate tables or materialization. Or perhaps using a different technology altogether, rather than relational, using an OLAP source. And how fresh does the data need to be? If you have to go after real-time data or extremely fresh data, you may have no option but to go against a transactional system. At some point you're going to ask yourself, which data source should I use for the most optimal performance? If you're going to analyze your data, and your data is highly structured, so it has hierarchies that you would like to drill up and drill down on, or you would like to do relative time comparisons of the data, so how did I do in one period versus another period, or look at rolling periods, for example, and the data is largely aggregated, then OLAP is an extremely proficient technology to provide you with fast reports or analyses. If you're going to go against a relational data source, then we highly recommend star schema versus an operational, also known as a transactional system. The reason we recommend star schemas is because it's an industry standard that our tools are optimized for. And that star schema design is a central fact table with its surrounding dimensions. And your data mart or warehouse can have multiple fact tables which can be related to each other through these common dimensions, also known as conform dimensions. So for example, sales fact could be related to sales targets through the time dimension. If you have to go after live data or extremely fresh data, then you have a couple of options. One is to do extremely frequent data loads into your warehouse, or go directly against the operational system itself. And if you are going to go against the operational system, then it's highly recommended to be extremely focused and highly filtered in your queries against that system. It's not recommended to use these transactional or operational systems for monthly or quarterly or yearly roll-ups. And of course, for relational systems, remember to take advantage of the use of aggregate tables or some form of materialization or partitioning of tables. Database vendors spend millions of dollars in optimization technologies. It's in your best interest to leverage these technologies. And the more you leverage within the database for optimization, the faster the reports are going to go. Let's quickly take a look at some of the IBM Cognos technologies available to you for your BI projects. For dimensional analyses, we have IBM Dynamic Cubes, which is our rollup offering. The relational sources used to feed these cubes must be in star schema format. They are great for large data volumes and are aggregate table aware. These dynamic cubes employ in-memory caching strategies for quick data retrieval. We also have IBM Cognos Power Cubes, which are tried, tested, and true, and is an OLAP technology. And then we have our OLAP-like technology, which is IBM Cognos Dimensionally Modeled Relational, or DMR. And these packages are recommended to be used with dynamic query mode, so that they can also employ a better in-memory caching strategy as discussed with the dynamic cubes. We also have IBM Cognos TM1 as another OLAP technology, and this is great for when writebacks are required, as is with planning applications. And some shops that already have TM1 for their planning applications may also choose to use it for their BI reporting. And for straight relational reporting, we have our standard IBM Cognos BI relational models. Again, designed and published with Framework Manager, as is DMR. And it is recommended to use star schema data sources. Again, because it's an industry standard and our tools are optimized for that structure.